I'd like to introduce now Rob Anex, who's a professor of biological systems engineering at UW-Madison. He's an expert in life cycle assessment and systems modeling, particularly as applied to decarbonization technologies and biobased products. His research focuses on prospective analysis of the economic and environmental impacts of policies and technologies in a changing global environment. With Dr. Wang, he's co-founder of Earth Repair Global Inc., a carbon capture and mineralization company based on technology developed at UW-Madison. Welcome, Rob. Thanks.
Thank you for inviting me, Mary. Given that the break's supposed to start in 5 minutes.
I think let's finish your presentation. We'll do the break after that, if that's all right.
Oh, good.
Yeah, that is fast. That is fast.
Let's see if I can make this work. All right. Yeah, thank you. Thank you very much. Now, do this. Ooh. So why should you care? Why should you care about LCA? Why am I here talking about this? Well, most of the conservation practices that get us environmental benefits cost money, right? They either cost money in actual inputs or equipment or in lost yield or increased management effort. So if we want producers, and I don't really know who you guys are. I'm used to, like Greg, I'm used to talking to farmers. And so when I say producers, everybody knows that really means farmer. Does that? Yeah, okay. So when I say producer, anyway, so if we want producers to deliver those advantages for society, well, we have to pay them. And the way we're doing that thus far, by and large, is through government programs that compensate or pay people to make the products that come from the agricultural goods in an environmentally preferable way, or through voluntary markets. And so here's a bunch of stuff. The Inflation Reduction Act grants tax credits for sustainable aviation fuel if it results in 50% fewer greenhouse gas emissions over its life cycle. And I've bolded life cycle because this is why you should care about me talking about life cycle. And pursuant to that, GEVO will pay 20 to 50 cents per bushel bonus to corn farmers using carbon reducing practices, whatever that may mean, to supply. But and how they will decide what that means is, I can't even see this. I don't know if you guys can see it. Again, I've bolded the GREET life cycle model. And sort of pay attention to that bullet, because I'm going to come back to several of those things in a few slides. The IRA also includes $19.5 billion over 5 years for USDA conservation programs. There are a bunch of state programs like the Low Carbon Fuel Standard and the Oregon Clean Fuels that pay people for producing an agriculturally derived product that is less carbon emitting than some baseline, right? And Greg did a fantastic job of talking about baseline and variability, and that'll save me a little bit of time when I get there on my slides. And there wasn't even room on this slide. Rosalind is a biogas company in Missouri. They're paying farmers to grow grasses, to basically restore prairies, the way that they say it, but it's really, they're making grasslands, and those grasses are harvested and fed into bioreactors to make renewable natural gas, right? Anaerobic digestion. So there are a bunch of these, and then there are a whole bunch of the voluntary markets. So if people all heard about Indigo, Indigo is probably the best known. They, in their initial valuation, were worth more than $1 billion, so they were a unicorn. And their whole business, right, is talking to farmers about how to do these carbon reducing activities that they can then make carbon offsets to sell into the carbon markets. Does everybody know what a carbon offset is, right? So we're gonna, yes, I'm gonna say it anyway, sort of. We're gonna reduce carbon emissions or remove carbon so that it can then be sold and offset activities somewhere else, right? So it is a financial instrument. And so suddenly, I didn't put any of them up here, but there are a whole bunch of these things popping up like mushrooms, right? So here are a whole bunch of people who want to work with farmers to do carbon offsets. And then there are more of them that to me are almost terrifying, that they are linking together carbon markets, agricultural carbon offsets, and blockchain, right? It's like, we can do cryptocurrency, and anyway, that's just a bit of a digression.
Yeah.
Okay, it's maybe more than a bit of a digression, but these guys, right? They want to do carbon offsets, so there are a whole series of important measures that they're gonna take to see just those things Greg was talking about, right? And I'm gonna actually come back to that. But is there a baseline? What is the baseline? Was it additionality? Is it permanent, et cetera? And these guys more and more are doing things that are life cycle related. And I would argue they're going to get pushed to do even more so. And I will try to make that point. All right, so what is life cycle assessment? I won't make this a long, boring LCA lecture, but the idea is that we're going to use this comprehensive over the life cycle analysis, or analysis over the life cycle, to avoid problem shifting, right? Either between stages of the life cycle or between impacts. So it should be a whole range of environmental impacts. It should evaluate a whole range. When we only evaluate one thing, like carbon, it isn't really LCA. It's now something like carbon footprint, but it basically follows all the same rules. All right, so problem shifting. Here's an example. The UC Davis life cycle folks did a study, and they said, well, what we find is that tomatoes produced in California and shipped by rail to Michigan will have a lower environmental impact than locally grown Michigan tomatoes. It doesn't sound instinctively right, does it? But I'm a Californian. I grew up by the Hunt's tomato factory. We used to go over the overpass and call it Mount Hunt. Anyway, tomatoes in California, they have really productive soil. They have huge efficiency, economies of scale, right? For per energy, and the soils are very productive. In Michigan, they have acidic soils that have to be limed, and that liming releases CO2. And I did say shipping by rail. So rail is really efficient. So I believe actually that the results are right. But if instead of shipping by rail, you ship by truck, suddenly the carbon footprint of those California tomatoes goes up by almost 50%. And you're definitely better off buying Michigan tomatoes. So that's just sort of what LCA is trying to get a handle on, right? If it really depends how you ship it, how you produce it, what the agricultural practices are, et cetera. And it let me show a really nice, pretty picture of the tomatoes. They're usually a little bit more complicated. LCAs are a little more complicated than that. The basic idea here is that we're looking at all the inputs and the environmental impacts of those, and all the wastes that come out and the environmental impacts of those. And again, I won't make this into a boring LCA lecture. Where tricky stuff happens are these boxes here, which I don't know if you can see this. When there are co-products, well, now the environmental impacts of those processes need to be divided amongst those, right? So there's this much carbon that's emitted, how much goes to here we're making lamb chops, right? So how much goes off to the hides and the wool and the offal and the other meat product, as opposed to that pork chop. And that can be really controversial because there isn't a clear answer of how you should do that. Anyway, so there are some tricky issues, and they've been controversial because that can have a huge impact on the output, right? If I can say, well, really a lot of the carbon belongs to the wool, so my lamb chop has very low carbon, right? It can really swing the result. And that's why this LCA has been very controversial in a number of things like biofuels. So these sorts of LCAs are typically done by people like me, engineers, or industrial ecologists, not agroecologists like Greg that was here. So, in both the previous slide and this one, you see that agriculture is just like this one little box. Agriculture, right? We're used to being able to go to a refinery and we measure stuff, and it's one site, and there, right? And refineries aren't that different. Okay, little variation between whatever, the Chevron and the mobile plant or something, but agriculture is not really like that. And LCAs don't honestly do a very good job of accounting for that variability. And Greg covered this beautifully, right? I mean, remember back to his discussion about the long-term experiments in Wisconsin and the long-term experiments in Michigan, and how one place it looks like carbon's going up and down, and yeah. So there's a huge amount of spatial variability in soils and weather. LCA is based on this idea of a functional unit, right? So like per tomato or per kilogram of tomato paste. And so, you know, this isn't a farming audience, but if you were a farming audience, there are good years and bad years. And farmers have acres that they lose money on every year, but they farm them because they're feeding the world, right? There are acres that you put more money into in terms of fertilizing and harvesting than you ever get back in terms of selling the product. So LCA has to average across regions, across soil types, or it should be specific, right? And I think Greg got at this pretty well, that if you're going to pay somebody to sequester carbon, you really need to measure what they are doing, not what the average farmer is doing, you know, across a region. And then there's a huge lever to spatial aggregation. And it, you know, if you think about just the last couple of years, especially in southern Nebraska and Kansas, we've had incredible droughts, and there have been fields where nothing is grown. You know, on a per functional unit, they've put a lot of inputs into producing almost no crop, right? I mean, suddenly those years look really, really bad. And I'll give you another example, which is Canada. Canada has huge extractive industries, like lots of mining and petroleum. And they've always been able to say as a nation, hey, our carbon balance is looking great because we've got all these forests. And it was true, but climate change affects forests too. And, you know, there's these nasty little needle miner moths and pests, and trees start dying. And the standing stock of trees, once they fall down and start releasing their carbon, turns out that since about 2019, the forests of Canada have actually been a carbon source rather than a sink. So they went from being a pretty big sink to a pretty big source just by, you know, you look like you don't understand. Yeah.
Fascinating.
Yeah, it's kind of terrifying, right? And well, yeah, enough said. I don't want to cut into our break too much. So a little bit of a case study of sustainable aviation fuel. This is, remember back to that bullet where I said GEVO is paying and they are using the GREET model. So sustainable aviation fuel is casting a huge shadow on the agricultural landscape. Isn't that cute? If you were to supply the renewable, you know, the sustainable aviation fuel, I should say, you can make SAF from oil seed and oil products. You can also make it from ethanol, so from corn grain to ethanol, or even more directly, drop in biofuels. And it isn't clear exactly how that will get done. But if you were to make it out of oil, the demand for supplying the aviation fuel we need from oils would be more than all the oils produced in North America right now, right? So North America's demand for aviation fuel would consume more than all the oils. So that's what I mean by it is a huge shadow, and everyone's really excited about it. Greg was saying soil carbon is suddenly such a hot topic. Sustainable aviation fuel is now just all over the place. I don't know if you've seen that, but the wording of the IRA that's giving out that money that I talked about in that bullet is this, and I don't know, maybe you can read that. I'll read it to you anyway, because I can't ever remember these acronyms. The IRA says that GHG emissions will be defined and certified by the Treasury Department in accordance with the standards adopted by the ICAO for the carbon offsetting and reduction scheme, blah, blah, CORSIA, or any similar methodology that satisfies the criteria of the Clean Air Act. So in come the LCA experts, right? The guys like me, we get to now argue for what the methodology is. And you know what's coming. It'll make a huge difference of whether you use Model A, Model B, or Model C. And in the interest of time, I won't dwell on that too much, but here's a comparison of those. So here, that's the Corsia one that was called out in the first column. And then here's the RFS model. And then here's the GREET model. And that was in that bullet too, right? That GEVO is going to use the GREET model. And the California Low Carbon Fuel Standard uses a California version of the GREET model. But this is made by engineers like me from Argonne Labs. In fact, the guy who's the father of this, I went to grad school with at Davis many years ago. But you can see, so the little dot is the net, right? And there's a pretty darn big difference between 90.8 and 35.7. And what's going on here, there's a couple of big effects. One are these, whatever that color is, sort of green color, is ILUC, right? So people know, I'm looking to see how many people are nodding. Indirect land use change, right? So if we start making a lot of biofuels, but there's still demand for food, we clear new land, or we convert grassland to prairie, or we cut down rainforests or tear up cerrado in Brazil. I mean, that's what ILUC is classically, but it's also going to be true in general that if you reduce yield, right? So if you start doing carbon smart agriculture, if you start doing conservation agriculture that reduces yield, there will be some ILUC. And that ILUC is modeled with, well, all right, so here's how that affects that change of agricultural production. Here's how it affects economic prices. And then, right, all the GTAP, the clever ag people say, okay, here's a general equilibrium model. Here's how that will affect demand and therefore land use change in other places in the world. So there's a whole bunch of assumptions built in there. And I'm not saying they're wrong because it's true. I mean, it is undeniably true that when prices go up, we see clearing of land. We see conservation reserve being turned into corn acres. And conversion of land is a huge source of CO2, right? When we take those prairies that Greg talked about that were built up over thousands of years and till the land, right? We can burn off a bunch of soil carbon really fast. The other factor that's on here is that this model, the GREET model, gives credits for soil carbon management. So if you're doing no-till instead of a moldboard plow, they're going to give you credit for that, which I think is on its face good. But again, this is a bunch of engineers who are making sort of averages across all the landscape and assumptions about how much conservation or how much carbon will build up, right? And remember Greg's curves of 20 to 50 years under certain practices, but a whole bunch of them were really negative. But there's assumptions in here that'll be positive. And basically, if this is adopted, and I'm not really arguing against it, I'm just saying, look, this is why LCA matters. If you adopt this, not only are these numbers huge, but you now are basically in a carbon offset business, right? Because you're giving credit for carbon sequestration without all the benefits safeguards that are existing in those carbon offset markets. And I'll say a few more words about those. Anyway, you get the idea. LCA is going to matter here, and it matters a lot. And so Greg also talked about these things pretty nicely. The reason that I really was talking about this is the carbon offset markets have already started to kind of fall apart in some cases, right? So you've seen The Guardian and Afforestation. The prices of carbon offsets have dropped 75 to 80% from their highs in 2020, 2021. They were a whole lot higher. And for the first time, the markets have actually shrunk. We're selling fewer carbon offsets because companies have backed away. They said, I don't believe in this stuff anymore. And that's potentially going to happen to a whole bunch of these programs if we don't pay attention to, is the LCA done right? Is it defensible? And that previous slide where I'm saying, well, then now you're in the carbon offset market, but without the safeguards. Carbon offset markets try to do these things, and we've already seen that they sort of fail. And just remember what Greg said about the baseline and the question about permanence, right? How is this stuff carbon really gonna stay in the soil? And is it additionality, right? Is it actually additional? Are we getting anything new, right? So if 35% roughly of farmers use no-till already, and I'm gonna pay farmers for doing no-till, you know, you've got to say, well, relative to what? Would they have done no-till anyway? Were they already doing no-till? Anyway, that's sort of what the idea of additionality is. And the pro-ends, I mean, so the one I just showed you, if you suddenly start using the GREET model, there's like no verification. It's just, here's what the model says. And even the carbon offset markets, most of them have verification when they're talking about agricultural soils that would go out and actually measure on about 1% of the actual soil. And there are ways to get around that, right? Under certain conditions, if you're doing certain things, you aren't even subject to that. Anyway, I don't mean to pick on any of this. I actually want to see us plant more prairies and do many conservation things and pay people for good measures. But as soon as the trust and the confidence in those markets falls apart, we're done. And none of this happens without a lot of money, right? Those markets have to exist and have to function, or, you know, I'm sorry, farmers have to pay the bills, right? And it costs money for conservation measures. So I think I'm pretty much done. That's why LCA matters, and a whole bunch of these things that have been pretty arcane LCA topics are suddenly becoming very relevant for a sustainable circular bioeconomy. And here basically it says that. There's a couple of things. If you want to actually, you know, lobby for changes, you really have to understand how LCA works and what those assumptions are. And I want to say the first part. Yes, LCA is just an accounting measure, right? I mean, it's just a bunch of accounting, but it's only as good as the accountants that put the numbers in. And I put GIGO in parentheses there because modelers all say garbage in, garbage out, right? It all depends on the assumptions. So, sorry.
Thank you, Rob.
Yeah, thank you.